Okay, welcome to C++. We're looking at Chapter 2 today. And I'm going to move right to our D2L course homepage under Content. And I'm looking at Unit 2 materials in the Unit 2 module. And we'll want to print the lesson plan and begin to complete it. And as I said, our lesson plans follow somewhat of a standard template format. Your directions to read and print this and study and do these activities for Chapter 2. Read Chapter 2, do the step-by-step directions, review the chapter summary. Your terminology and review self-help exercises are found at the end of the chapter. And of interest, I'm pointing out to you as we begin to declare our data types for our variables. We have a list of variable data types and their associated size in bytes. So each data type requires a certain amount of memory storage. And memory is typically measured in bytes. And you may or may not know that each byte is made up of 8 bits. So we can see that there's a difference in size capacity for different data types, like our integers, our floats, our doubles, and our location in memory has to be available internally for these bytes to be assigned to a data type with a variable name. Now, assigning and finding that memory location that has the available unused memory area for this byte size is done internally. So we don't have to worry about that at this point, but we should at least realize that with care, we want to be naming our data types. If a particular data type, short int, for example, might work for our program rather than a double, then maybe we should be looking at size capacity for our data types and being sure that we're using memory wisely. After all, memory is very costly to our organization, and you would be expected to program with those size capacities in mind. As we continue, the chapter exercises are assigned with our Word document. You type your answers only. Be sure to include that required header. Upload appropriately, and your assignments are listed. There's no shared sample code for this example. No online discussion at this point. Your program project, however, is listed. You'll place your program project in the appropriate Dropbox category assignment area of D2L. And so at the top in the assignments menu, click and follow the download direction. Follow the directions to upload your document or documents to the correct category. I will expect your source code and the Word output screenshot or screen capture. And your program assignment is on page 69. Exercise 2.19. Use Visual C++ to create your original source code, build and run your project. I will expect the uploaded file name .cpp, so I need a copy uploaded of your source code, the .cpp file, which is your original source code that you type or create, and a Word document uploaded containing the screenshot of your executed program, which is again at that black screen, the command line. That's your output. Any Word document requires your header. And of course, complete the chapter test at D2L quizzes. Okay, we'll come back to that. And always come back to D2L and your unit lesson plan for final details on projects and assignments, due dates, etc. So let's look at chapter 2. So I'm on page 45, the first page in chapter 2. And we're just going to be getting an introduction to our first program. And it happens to have been shared with you in your example folder. So let's experiment. Again, this will be repetitive from now on, but let's experiment with finding this shared program. So we have figure 2.1. It's our first CPP file, which contains source code shared by the author. So remember, we have downloaded our student data files on our C drive in an examples folder. Open that readable code, and in chapter 2, you'll need to right click on the zip folder and extract it, and then open that those readable files that were zipped for us and shared from our author. And we want to look at the source code for figure 02.01. So I'm going to double click on that. If needed or requested, be sure to open in Notepad or right click and edit in Notepad++. Now, if you have not downloaded Notepad++, please go ahead and do that. Download Notepad++. And just go to the internet and do that. And so we're going to open in Notepad++. And there, unlike Notepad has nice line numbering for us and some variation in syntax, some understanding of rules of C++ with indentation and so on. So that's a nicer editor to review our source code in. So we begin with the first line, and we notice these //. The // allows us to create a single line comment or a single line piece of documentation. And that single line comment can contain any characters, upper lowercase, spacing, special characters from the keyboard. Nothing will be compiled or used or change your programming source code. These are comments only left for you and, more importantly, for your programming team members as you may revisit this code in the future. Here we have another // for a single line comment. On page 42 in your book, you can also use comments containing one or more lines. And there we would include multiple line comments with the /* and your comment, enter key, another line, enter key, another line, enter key, another line, and then our final multiple line comment, and then your star / to close. So multiple line comments can be enclosed within the / star and the star /. So a couple of ways to make use of preparing your comments within your beginning documentation. Now, beginning documentation, of course, is at the beginning of our program, and you have requirements at D2L Brightspace for your beginning program documentation requirements. So be sure to check that again under your student resources module. Well, then we see our first # include IO stream. We're just looking carefully at syntax now. It's a # include space less than symbol IO stream greater than symbol, and then we're commenting. Here we have a single line comment / and we're just documenting this source code statement. It enables the program to output data to the screen. So something we'll want to do in order to let the user know what has been produced for output. Line 5 is another single line comment with the //, and it's documenting that function main begins program execution, and every C program begins its program execution at the main function. Notice that we have int space main and then open close parentheses. There's no space after the end. Main open close, and then a space, and we have a forward brace. Now that brace indicates that we're starting a body of code. You can place that brace on the next line and have it a standalone open brace with its matching close brace, and see how Notepad++ does kind of document that for us visually. We have an open. Whenever you have an open brace, you're going to have a closing brace, and we see that kind of indication there. And that bracing, the open and close brace, is bracing or documenting a body of code. And this body of code then within the open close brace is the body of code for the main function. Our next statement is std : cout. Now the std is a directive, a statement we have to use to qualify : no spacing, cout. Cout means that we're going to direct our output to the standard console unit, which your standard output device is your screen. So display the output to the standard console. And we use the less than. We say that the C console is getting this string. And this string of data between the open and close quotes will be quoted exactly to the output standard device. So what's within quotes will be quoted. So we should see welcome to C++ ! But then notice this \n. That's one of our new escape sequence characters on page 48, where the \n will force a new line on your output screen. So we're going to see welcome to C+! ! And then a blank line on our output device. Return 0 indicates that the program ended successfully and we're at the end of main. So we've been able to kind of chat through this program. So dissecting the lines of code together, I'd like to just close this and go back to page 49, where we added a program. Again, this is a shared example from your author. So I'm on page 49 and we're looking at figure 2.3. Our comment says we're going to print a line of text with multiple statements. Now your author, as they present source code, as it varies from a previous program, it'll be highlighted or highlighted lightly in blue to indicate that these are new statements that we may or may not have looked at previously. So in this program, we want to print a line of text with multiple statements to the output device. So we have our int main function, open and close matching braces, and we're going to output what's quoted within the quotes to the standard console output device, which is our screen. So we're going to print welcome with a space. Notice that there is a blank space in this quote, quoted. So we'll be typing uppercase, W, and then lowercase welcome, space. We end our C++ statements with the semicolon. And then the standard output console device is going to get the quote to space C++ exclamation point, continuing on one line. And now we're done with this line of output. So we're going to force a new line with the escape character \n, close quote. So again, I'm in my examples folder where I've downloaded my student data files and extracted them. And I'm looking at program figure 0203. And let's go ahead and run this program as a new project in Visual Basic. Close my start screen, file a new project. I am using Visual C++ as a Windows desktop environment with the Windows console application for my output. The name of this will be figure 02_03. Browse to the correct destination, and I want to be in my first name folder now. I want to be working with chapter 2 data, so let's go ahead and make a new folder for chapter 02 projects. And open that folder, select it. Notice that our path is correct. This is in my first name on the C drive, organized with chapter 2 materials. And that my program name, figure 02_03, has populated to the solution name as well. Create a subdirectory for this solution is checked and say OK. Your Visual Studio environment is populating to your screen. Be sure to maximize. Arrange your Solution Explorer window if you have not. And we do that through the View Solution Explorer. Click on it, and then it may float somewhere on your screen, and do a right click in the title bar and dock it as a tab document. Now our figure 02_03 project knows it needs a source code, so it's opening our .cpp file by default for minimum code. And I don't need this. I actually have what's shared from my author. So I'm going to go over to my Solution Explorer and delete this file. by removing it, a right click, remove, and then delete. And immediately go to my Explorer where I have my solution file shared from the author. I'm just going to drag it over to the source files in my Solution Explorer. And it populates figure 02_03.cpp. Now I'm interested in that source code, of course. So click on it and it will populate back to your editor, your working area. Now, if you haven't turned on line numbers, you'll want to do so, and that is customizing your environment. Type line numbers in the quick launch find, enter, and we are making certain that line numbers is checked. And you shouldn't have to do that over and over, but as a customization reminder, we've discussed it, just kind of again set up for your first few programs here. And then we've talked about in our handout installing C++ that you do need to include the pound site includes standard AFX file, but you see it is already populated here. Remember, we are using a shared file from our author, so it's already there. We don't have to use that particular syntax, and the header is in the header file. Standard afx.h is already in the header files. Again, we're inheriting, we're sharing this file. The author has already shared that with us, so we don't have to take care of that step individually. Then we want to set the project properties. Choose project properties. And under C++, precompiled headers, choose the precompiled header, pull down arrow and say not using precompiled headers. Apply and say OK. With these changes, let's go ahead and save all and run. And I saw something flash on my screen like a black command line screen, but it wasn't held on my output device. So recall from our discussion with installing C++, so keep that handout handy for you. We need to continue to edit this code in the main function area. We're going to add system, pause, system, no space, open paren, quotes, pause, end quotes, end paren, and the semicolon, and return 0. Now we've made a change, so let's go ahead and save all again and try running again. Now this time, because of our edited code, the system is going to pause the output command window, which is our black background window, and it automatically produces this press any key to continue. I haven't coded that. The system pause codes that. So we have welcome to C++ exclamation point, new line, press any key to continue. And that's exactly what we asked our program to do. Produce output to the standard console, welcome space, to space C++, to space C++, exclamation point, and then force a new line, and the system prompts us with press any key to continue. Now this is your output screen. If you were following up with submitting this CPP source code and this output screen, you would be using, hopefully, your snipping tool or your screen capture keystrokes at your device to capture at a minimum the output of this program. And then we paste this into your Word document, create your required header, and be prepared to upload that as part of your required uploaded materials. All right, we're done viewing our output. It looks correct. I've made sure that spaces are attended to. Welcome space. We wouldn't want the E and the T exactly back to back. We do want that space between words, so it has to be quoted. It's welcome space within the quotes. We are satisfied with this, so I'm going to do save all, file close solution, and file exit. I'll return to Visual Studio with my next project when I'm ready, but in the meantime, I'm protecting my Star ID account. All right, we're going to look at another program. This is 2.4, section 2.4 in your textbook, and it is also a shared example in your student data files. Now, as the author presents a new program in the narrative of each chapter, the source code is presented. Typically, an example of the output. Right in this box, we have the output example. And then the following narrative, the author is dissecting the code with you. So be sure to read all of that material because the author is dissecting the code as I am at this point with you. And this is figure 2.5. So I have the downloaded figure 2.5. As source code in my examples folder. So I want to work through this program with Visual Studio. And create a new project. C++ Windows Desktop, Windows Console, and I'm going to name this figure 0205. As the author did. I want it to populate to my first name, Kate, on the C drive in Chapter 2. I'm still studying Chapter 2 materials. And my project name has populated to my solution name automatically. Create the directory and say OK. Again, this is the minimum configuration for a C++ program, and it's given to us by default. So I'm going to go over to source code files. I don't need to use this at all because the author has supplied us with the source code file for this project. So I'm going to go out to my Explorer. In my example subdirectory for chapter 2, I find the program figure 0205.cpp, my source code, shared with me from the author. It's going to drag that over to the source code folder in the Solution Explorer. And sure enough, there it populates, and here's the syntax that's shared by the author. And this is on page 50. Now again, we begin with beginning documentation. I'm using the / for single statement comments. Remember, we have that alternative / star for multiple statements enclosed within the star / closure. This is an addition program that displays the sum of two integers. We have our # include IO stream. Again, it enables us to perform input and output activities. Our output will be directed to the standard console unit, and our input is captured from the standard keyboard device. We document with documentation. The function main begins our program execution, and then we have int space main open close paren space open brace. Again, that can be on a single separate line immediately following main so that I have my open and close bracing. And you see that documentation kind of line on my main function has its open brace and its close brace. We have a documentation statement again with / and we are declaring and initializing variables. And that's exactly what we're going to do. We're declaring our variable names to their data type. Now, when you declare a variable, we are giving it a name. It must have a type, and it will have a size. Now, if you remember, I provided in your unit lesson plan that character, integer, short integer, float, double, long, those byte sizes. So in memory, we are asking for an integer size by the name of number 1 to be found for that size, and its data type will be integer, and we're going to immediately assign with the brace 0 close brace, we're going to initialize our variable by the name of number 1 to 0. So we have a given chosen valid name with valid naming schemes for variables, which you will need to read about and understand as you continue reading the chapter. It's a unique variable name. It is going to contain an integer, and I've initialized it to 0. I have an integer declared number 2 variable that's initialized with the brace open and close brace to 0. And I'm initializing an integer variable by the name of sum with the open and close brace to 0. And I'm documenting each of those lines. The first integer initialized to 0, a second integer initialized to 0, and sum will be the sum of number 1 and number 2, but is initialized to 0. So when we declare a variable, it will have a variable unique name, with a data type, and a size. So it's going to be allocated memory size location. So we've declared number 1, and it's going to take that byte size of capacity and available memory. We don't know where it's physically going to be located, but the system assures us that the byte size capacity will be available for an integer, and it knows it can locate our integer by the variable name of number 1. I'm just going to make this look kind of silly because we have number 2. It's been named, and it has a byte size capacity and available memory somewhere. You don't have to worry about that. And we have a sum variable assigned and located somewhere in primary memory with the capacity size of an integer. Now, when we named and declared a data type with the size of int, we also initialized the starting value to 0. So number 1 has been assigned an integer by the value of 0. Number 2 has been initialized to a value of 0, and sum has been initialized to a value of 0. Now, as we run this program for the first time, reading through the chapter, we're suggested to use our example where I type in 42 for number 1, or 45, I guess, 45 as the first example, and for number 2, type in 72 for the first example. And sum will be recalculated to 117. Now notice that when I assign initially 0, and then keyboard input, assign the user's input number, which I'm typing is 45, it is called a destructive operation. What was stored in that number 1 identified variable integer location has been removed, overwritten with the integer 45. Number 2 is initialized to 0, but when the user types a new assignment, 72, the old value is gone, removed, overwritten, and number 2 is housing the new value, 72. We call that a destructive operation. And then when we complete the calculation, sum is overwritten with the sum of number 1 and number 2. At this point, number 1 is 45, number 2 is 72. Adding, we get 117, which overwrites 0 with the current value of 117. So let's see if we can get our program to run. We've copied the author's source code. My line numbers are set. The standard afx.cpp and header file exist. I'm checking. It looks like I should add in main, so I'm within the bracing body of main, and I'm going to add my system pause. So the system will be held on output, and I'll have a prompt as a user to press any key to continue, but I'll have a chance to view and review the output screen before it goes away and then return 0. I'm going to do our project. We need to set our project properties for C++. preprocessor. I guess we'll see what happens. That looks a little bit different this time. Let's do a file save all with those corrections, and we're ready to try to run. Okay, it's suggesting that I add # include, so let's see if we need to do that. Usually you get pretty good hints from your compiler. Okay, let's try again. File save all. Try execution. I'm kind of guessing here right now why this is not working. Kind of erroneous examples right here, so it looks like I'm going to have to stop the video, and I'll come back with a correction or explain why this did not work when I get that figured out. It's inherited from the author, so we'll do a file save all, close the solution, and file exit, and I'll terminate the video and return. We're working on page 50.